Okay, on our previous video, we were talking about our limits involving infinity, and we had made it to where we started. Example 3, where we're just supposed to find n behavior, asymptote algebraically and support graphically. And I'm really overdoing this a little bit, because a lot of your assignment is just going to tell you, just find the asymptotes, and we can find the asymptotes without graphing. And we can find the behaviors, we approach the asymptotes without graphing. I'm going to start this over and just organize it, because yesterday I was a little bit all over the place, just trying to get graphs up there. If you're going to graph rational functions, I call it the 3 zeros. The first thing we might want to do is set the numerator equal to 0, then the denominator equal to 0, and then x equal to 0. Each of those give us some valuable information, and none of them are generally too challenging for us. And then the last thing I want to do is the big X test. So when the numerator is 0, I set this guy equal to 0. We determined it doesn't factor yesterday. If I go quadratic formula, the discriminant is we get the square root of b squared, -1 squared is 1, minus 4 times 3 times 5, but that's negative. There are no zeros, so there are none. And we said, well, that's too bad. I didn't find out any zeros, because when the numerator is 0, the function's 0. But it's not. I don't look at it that way. I look at that as a big positive. No, I didn't get any points on the graph at 0, at y equals 0, but I know that there's no passage through there. I can't ever cross through there. That doesn't mean that that's an asymptote, but I know that I cannot cross through y equals 0. Think of it this way. This is our street. Below is the sewer and the rats and all that, and above is buildings and above street level. The only way I can get through is if there's a manhole cover somewhere, pop up through. Just do the gopher thing. There are no gopher holes or manhole covers here. If I'm down here, I'm staying down here. If I'm up here, I'm staying up here. Is that all right? Okay, denominator equals 0. Well, that one quickly reveals x squared minus 4 equals 0. X squared is 4. X is plus or minus 2. But the denominator cannot be 0. And if the value in the denominator gives us 0, and it doesn't give us 0 up here, in other words, let's say if I could have solved the numerator equal to 0 and 2 was a solution, and it was a solution down in the denominator, that's a hole in the graph. But there were no solutions here, so these are vertical asymptotes, and we got those drawn in yesterday. And then x equals 0. Why? Just because it's easy. We're going to need some guidance where to put some points and fill in the graph, but x equals 0 is so easy. When I put in 0, I get 0, 0, 0, 5 on -4, -5/4. It's just an easy point. 0, -5/4. So I just got a point on the curve here. Big X test. When x gets huge, this x doesn't really matter anymore. You say, oh, if x is a billion, yeah, that matters. Lost $1 billion. Not if you had 3 times $1 billion, it wouldn't mean much. Right? This is dominant. This is dominant. So when x gets huge, this graph wants to look like 3x squared on x squared. It wants to look like 3. Y wants to become 3. And that is the limit as x approaches infinity and negative infinity. So we've been doing limits since we've been graphing rational functions. Back 2 years ago, in Honors Algebra 2, you probably were graphing rational expressions. You were doing limits at infinity. So that's where this guy comes from. Okay, so now I've only got 1 point on here. Things I know. Can't cross through here. But I expect my function exists over here, beyond 2. So, A or B. I could choose 3 and find out where I am. I could add 3 to my T-chart. Don't have to, at least to know if I'm in A or B. Can't be in B. The mole people have no way to come up here and become the regular people, right? There is no passage here. So our little mole men would be getting sucked into this asymptote. They have to have a little manhole cover. So the graph looks something like this. Now, if we need a more accurate graph, yeah, we should put 3 in, because I wouldn't be surprised if this gets closer in here. But our graph looks like this. Likewise, C or D, no passage through for the mole men. I like that one. I just thought of that. I'm going to use it. We got to look like this. Now, might it come in closer? Yeah, we might need to pick -3. All right. How about here? What do you think? Looks sort of like a cubic going up? Looks sort of like a cubic going down? Look maybe kind of like a parabola going up. It wouldn't be a parabola or a cubic, but look kind of like a parabola going down. Or should we choose one and figure out where that next point is and choose -1? Understand, we can pass through horizontal asymptotes. But this is a mole person. Can't pass through 0. Not today. So it's going to look something like this. Now, I don't even know if that's the relative maximum. It might be skewed to one side or another. But sometimes when we're talking about what's happening at the asymptotes, that's all I need. And the question the book's going to ask, they're going to just say, find the end behavior algebraically. Well, our end behavior algebraically is we're approaching 3. They might say, what's the behavior at the vertical asymptotes? Well, from the right of 2, we're approaching infinity. From the left of 2, we're approaching -infinity. What's the limit at 2? It doesn't exist. At -2 from the right, we're approaching -infinity. -2 to the left, we're approaching infinity. The limit at -2 does not exist. Is that all right? So I don't have to have a full exact graph, but I think the thing that people miss the most is the mole people. They can't get up there. Let's say on another, like here, my mole people, I had 1, 0. That was their only chance to get through there. This had to go up. Couldn't come through. Couldn't come through. Okay? All right, so let's go through this with a more systematic approach than what we did yesterday. We'll go through this guy. So we've got, let's let the numerator equal 0. And my first thought is, it's quadratic, maybe it factors. And I see 3 and 2, and I'm thinking 3 and 1, but that would have to be -3 and +1 to be -2. And -3 times +1 is -3, it doesn't factor. So opposite of b, plus or minus square root b squared, that's 4, minus 4 times a times c, and I don't have to do any more. I could put 2 times 1 down here, but this is negative. Which tells me my mole man aren't going to see their shadows. Right? Okay. We will never hit 0. Denominator equals 0. Gives us x equals 2, but the denominator, x equals -2, but the denominator cannot equal 0. Therefore, we've got an asymptote. Again, we're probably doing more than we need to do right now. Good training, though. What's my next test for 0? X equals 0. Why? Yeah, it just gives us an easy point. This is to help with the graphing only, not the asymptotes. I could be done with this problem perhaps by now. I guess I'd have to do big X test. So I put in 0. I get 0, 0, 0, 3/2. It's just too easy to pass up. 0, 3/2. Got it right? Next. Big X test. That's what we called it in pre-calculus. What is it really? It's the limit as we approach infinity. What's happening? As we approach infinity, 2x doesn't matter. 3 barely matters either. 2 barely matters. This wants to look like x squared on x. This wants to look like x. Now, understand, y equals x looks like this. But this looks like that as well. And this looks like that as well. If we're going to sketch the graph, we need an asymptote. We need to long divide and figure it out. But if I don't need to sketch the graph and they're just saying, what's the end model behavior to the right, to infinity, we're approaching infinity. To negative infinity, as I move left, we're approaching negative infinity on any of those. So again, this is more than what we have to do unless we have to get an accurate graph. So let's go ahead and do that part though. So I'm going to long divide x plus 2 into x squared minus 2x plus 3. And x goes into x squared x times. Gives me x squared x times 2 plus 2x. What do? Subtract. Subtract. And I get negative 4x plus 3. X goes into negative 4x, negative 4 times. After that, I don't care that there's a little bit extra. What that little bit extra is saying you're not going to get to the asymptote. You're going to look like x minus 4, but you're never quite going to be there. You're going to be off by just a little bit. So we've got asymptote, down 4, going up 1 over 1. I know everything I need to know about this to talk about the limits. We got it all. This graph, it's going to go here. It's going to go here. How's it get there? Well, how far down do I go? Do I go down and touch, or go down below, or stay above? Gotta stay above. There's no passage. There's no zeros here. Maybe this is the lowest point. Maybe it goes low and comes back up. Maybe it goes through here and keeps going down and gets close to 0, but I know it doesn't get there. But the general shape is something like that. Right? A or B. One finger A, 2 fingers B, 3 fingers not sure yet. Yeah, it's 2 fingers. Got to be in B. There's no way through here. Can't look like this. There's graphs that do, not this one. Now, if I needed to know exactly where I was down in here, I would probably choose x negative 3 and add it to my t-chart over here and go through the process. No big deal. I suspect maybe there's some kind of symmetry here, so maybe this thing doesn't even appear till like in there, but really for our purposes, we've got what we need. Anything they can ask about limits, I can answer now. What's the limit at infinity? Infinity. What's the limit at negative infinity? Negative infinity. What's the limit at negative 2? Doesn't exist. What's the limit at negative 2 from the right? Infinity. What's the limit at negative 2 from the left? Negative infinity. Okay. 80% of answers lie in the graph. We okay there? Any questions?